Hi, this video will be about some basic features of signals. I will do some repetition on the signals, guys, which we have covered last week. And then I will jump into the specific information about signals, their types, certain basic signals that we will be dealing with for the next part of the subcomponent. So I would like to give you an introduction to signals in this video. So if you remember that we have discussed the signals are functions of independent variables. They carry information, and we have we have discussed about several types of signals like acoustic signals, electrical signals, or video signals, images. So all of these have different aspects in them, right? They may show our speech, they may show our, let's say, our images, or they may indicate the voltages that we are measuring from a sensor. And we also talked about different properties of signals. Signals can be continuous or discrete, and the number of independent variables determine the dimension of our signal. So a signal like an EEG signal might be a 1D signal, an image might be a 2D signal, a video is a 3D signal, three-dimensional object which is moving like a hologram or like a fetal image, ultrasound image, might be a 4D signal. So when we deal with these continuous signals, we will be using X of t terminology, and when we talk about discrete signals, we will be talking about X of n. So these are important. T's are continuous values. It might be 0.025 or something like that. And n will be like -2, -1, 0, 1, and so on. So these will be sample values, integers only. This might be any value which is like a real number. So when we talk about the classes of signals, guys, we will be talking about continuous time, discrete time signals, which we have covered before, and even an odd signals. In the high school, we were talking about even functions, çift fonksiyonlar, or odd functions, tek fonksiyonlar. So we will do the similar thing here. We will talk about periodic signals and non-periodic or aperiodic signals. And also, finally, we will be talking about deterministic and random signals. When we start talking about continuous time signals, we have values, voltages, or temperature values for all time instants. That's the critical part of continuous time signals. When we talk about discrete time signals, we don't have values for all time instants, but we have only samples as we discussed here, okay? This is like -2, -1, 0, 1, and 2 are my samples. This is the sampled version of the continuous time. Usually that's how we obtain discrete time signals. And when we talk about the difference between continuous time, discrete time, and digital signals, here is an explanation of that. We sample the continuous time signal, and we have a discrete time analog signal. Then we convert them into discrete time signals by giving them some codes, code words, using quantizing and encoding. Each value will have some bits, zeros or ones, as I mentioned you last week. So let's try to talk about even and odd signals. So what is the even signals definition? For an even signal, such as this one, like the value on the positive side, let's say this is 1 second, and in the -1 second, they have the same values, okay? For example, for cosine function, okay, this is my cosine function, and the value here is the same as the value here. The value here is the same as the value here. So A cosine signal, cosine t, for example, is an even signal. If we talk about an odd signal, let me remind you, there is a symmetricity around the y-axis in even signals. So there is a symmetric situation. For the odd signals, the symmetricity is around this origin, okay? So if this is 1, let's say this is 1 volt, at minus 1 seconds, it should be minus 1 volt, okay? So this is critical for odd signals. If the time is negated, if we take the negative of the time, the function itself, the value of the function is going to be negated also. Okay, that's critical here. For example, a sine wave, a sinusoidal wave or sine of t is going to be something like that. And here, if I take the value here, let's say at 1 second, in the minus 1 second, the value will be negated, will be the opposite sign. Okay, sine of t will be an odd number or odd signal. So let me show you these here, and then you will see how the odd and even signals can be represented as like using the functions themselves and using the graphs. For example, x of t is equal to c. What does it mean? My x of t is constant at c volts, for example, and this constant signal is always an even signal, okay? So this is also critical that you need to know this. For example, x of t is equal to t, like this, right? X of t, this is t, this is x of t. If t is 1, the output is 1. If t is 2, output is 2. If t is minus 1, output is minus 1. If t is minus 2, output or the function value is minus 2. So this is x of t. So this is an odd signal or odd function because the values are changing when we negate the time, like from 1 to minus 1, from 2 to minus 2, the values are changing from 2 to minus 2, okay? So these are even and odd signals. Okay, the first class of signals was related to continuous time, discrete time. The second class was about even and odd signals. Now I would like to talk about periodic signals. Okay, in this subcomponent, signals and systems, we will always be dealing with periodic signals. So periodic signals repeat themselves at every certain time period, okay? For example, a sinusoidal signal, as I mentioned before, okay, this is my sample sine wave, for example. It will repeat itself at every t seconds. This is 0, this is t, this is 2t, okay? And this should be true for all possible t values. So this is my t. This is like, let's say if it is minus 0.5 seconds, after t minus 0.5 seconds, this value is the same. Okay, so this t will be my period. This is going to be my period, and it is in seconds, and t is going to be always greater than 0. This is critical. This should be true that for all t values, this has to be attained. Okay, for example, a square wave like that, a periodic signal. Okay, so this is, let's say, 0, this is t, this is 2t. For all t values, there is a repetition. Okay, so periodic signals are at every time instant, the signal repeats itself for t after t seconds. For example, guys, if we talk about cosine functions, the period is 2 pi, okay? So if you think about the sine wave, for example, after 2 pi radians, we will be talking about radians or time in seconds in this class. So this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi, okay? You know pi over 2 is 90 degrees. This is 180 degrees, 270 degrees, and this is like 360 degrees. So sine 90, what is it? This is 1, right? Sine 180 degrees, it is 0. Sine 360 degrees, again 0. So at every, and if you think about this, like this is going to be like 360 degrees later, degrees plus 360 degrees, it will still be 1. So this is going to be my period. Period might be in degrees, in radians, or in time. Okay, time might be 1 second, 2 seconds. It will depend on the frequency of my signal, okay, which I will talk later. So another important classification will be deterministic signal versus random signal. In this class, in this subcomponent, we will not be dealing with random signals very often. But in your project, random signals, like EEG is a kind of random signal. So you will be dealing with random signals on the way. But let us determine, or let us understand what is deterministic signal. If I can know any signal beforehand, any value that can occur beforehand, like either using a mathematical function or I can predict it from the past values, then I say this is deterministic, okay? For example, for a sine value, for a sinusoidal signal, can I, and this is given as like 2 sine t. Can I know what the value is for t is equal to 0? Yes, I can put it here, sine 0, right? And it will be 0. And for t is equal to, let's say, 0.5, then I can go and find out sine 0.5 and write it over here. So this is a deterministic signal. I know it beforehand, either using mathematical functions or I can predict it from past values. If I cannot know a function, a value, a time value at a certain time instant beforehand, then it is called a random signal. I cannot know let's say in 10 seconds what will be my brainwave value, voltage value that I can obtain from the brain. I may not know it, okay? I will not be knowing it usually, okay? So this is a random signal example. And noise, like you will be seeing these kind of noise in your signals, like these are random noise, and you will not be able to understand or predict or calculate like what the value is for like 10.2 seconds. We don't know it, okay? We don't know beforehand. So it's a random signal. So this is the first part of this video, and I hope you got the main idea. Now I wanna move on to the second part in the next video.